Let's look at examples from the tutorial, and then I'm going to go over the exercises as well. So the first example is like what I did earlier, what I showed you earlier in the functions video. In this example, basically you have this equation that you want to evaluate using a function. So it's pretty much the same thing as I discussed with you earlier. We did two outputs. Here you have only one output, so you don't have to create, you don't have to put them in the squared bracket. And there's only one input variable x. In the exercise that I showed you, you had two input variables. So this is pretty much similar to what we did. Actually, it is simpler. So read all this thing. You're gonna see some other stuff. Output, I'm mentioning you have to be standing in the same folder from where you're calling the function and all those things. Okay. All right. Again, something that I already mentioned, that in functions we don't use input and we don't print out the output using the fprintf function. So keep that in mind, please. Example 15. In this example, basically user is giving you a complex number in Cartesian form or rectangular form, x plus jy, and then you have to convert that into polar form. That is, you have to calculate the magnitude of that and you have to calculate the angle of that. So the output of these functions, there are two outputs: magnitude represented by r and angle represented by t. And then my function name is rect2pol, rect underscore to underscore pol, and then input is my rectangular complex number. Now in this one, there is a condition that I'm putting, that the output angle should be in degrees, not in radians. So I went ahead and I extracted the real part of input and imaginary part of the input in two variables, and then I use the built-in MATLAB function which is called cart2pol. And in cart2pol, if you check help of cart2pol, cart2pol has two outputs. The first output is angle, which is given in radians, and the second output is magnitude. And the input of cart2pol function is x, that is the real part of the rectangular number, and y, imaginary part of the rectangular number. So I use that built-in MATLAB function and I calculated the output angle in radians and the magnitude, corresponding magnitude of the complex number. And then my output variables are r and t. So I went ahead and I assigned r the value of w, which is of course the magnitude, and t is the angle but in radians. So I went ahead and changed that into degrees by multiplying q by 180 and dividing by pi. So my r and t, which are my output variables, in this order: first is the radius or magnitude, and second is the angle, corresponding angle in degrees. So this is a program, this is a function that will convert any input value, any input complex number given in rectangular form, and it is going to give you the equivalent value of the number into polar form. That is going to give you two variables: magnitude of the number in polar form and angle of the number in polar form, and angle will be in degrees. So check out the sample output, make sure you create this function, and then check it yourself to see if everything is working. Alright, the first exercise, exercise 14. So in this exercise, you're making a function with the name, your first name underscore last name underscore exercise 14, right? So your function name, as if I go to example, your function name rect2pol here is going to be replaced by, let's say, your first name underscore last name underscore ex14, because remember, you have to save the function with the same name. You have to save the function file with the same name as the function name. Okay, and then in this program, in this exercise, you're creating a function which is opposite of the one that I showed you in the last exercise. That is, in this function, user is going to give you two values as input, and those values will be magnitude of a complex number and phase of the complex number, and you have to give the corresponding Cartesian form of the complex number. Okay, so you have one output variable, because complex Cartesian form of the complex number x plus jy is a single variable. So you have one output variable and you have two input variables, and a sample output is here. I'm calling a function, calling the function which I saved with my name, and my output variable is x, and the input variables are magnitude and angle in degrees. So any variable that you want to take, r comma t or a comma b, whatever. So when I executed my function, when I called my function, not executed, sorry, when I called my function with these values of input, 5 magnitude, 63 degrees angle, then my equivalent complex number in rectangular form will be 2.27 plus 4.45 I. Okay. Now there's a hint that I'm giving you. You can use MATLAB built-in function pole to cart as part of your program, like I used cart to pole here, right? Or rectangular, cart to pole in this one. So explore that function pole to cart. How does it work? Check help of that function, help pole to cart. Or another easy way to do that is, many of you already know how to convert the polar form into rectangular form, right? So if you have angle and magnitude, what do you do to get the real part of the complex number? X equals magnitude times cosine of the angle, right? And then imaginary part y equals magnitude times sine of the angle. And then you can combine both x and y, put x plus I times y. I is of course the imaginary, x plus I times y, and that you can assign as the output variable. So that's how you can do that, very easy. There is also a function in MATLAB which is called complex, and check help of the complex, and that you can also use to create a complex number from two different numbers, x and y. So any which way you want to do it. So that's exercise 14. And exercise 15 is pretty much the same exercise as I showed you in the tutorial of or in the video of the function, where you have three output variables, s, t, and u, which are three equations given by these three equations, and then you have three input variables, x, y, and z. And x, y, and z can be either, of course, scalars, vector, or matrices. So it's pretty similar, exactly same actually, I would say, exactly same as the program that we created in the video of functions. So this is very straightforward, and you can do it very easily. So this is the description of these two exercises.